Welcome to part two of our All About Lenses video. In this section, we're going to do an example of a converging lens. So we're going to start off with the example one from your notes, an object far away from the lens. So we're way past 2F here. So our scenario, we got a 1 meter tall flower. It's located 10 meters away from a converging lens, which is a convex lens, with a focal length of 2 meters. Find the image distance, the magnification of the image, and the height of the image. Then we're going to classify the image. So here's a picture of what we got going on. We got our sunflower all the way on the left, 10 meters from our lens in the middle. Focal point is on the right because it's a converging lens. Then we got our center of curvature at twice that distance. So start out with our givens. Right, so 1 meter, that's our height of the object because it says 1 meter tall flower. Flower is the object, so its height, HO, is 1 meter. 10 meters is the object's distance because that's how far away it is from the lens. Remember, we always measure our distances from the lens. So DO is 10 meters. And then our focal length, our F, is 2 meters. Next thing we got to find is our unknowns. Obviously, our image distance, our die, our magnification, big M, and the height of our image, high, are our three unknowns. So we're going to start finding out our image distance. So we're going to pick the correct equation, right? There's two equations with die in it. 1 over F equals 1 over DI plus 1 over DO, or M equals negative DI over DO. Since we don't have our M, we can't use the magnification equation. So we got to use our lens equation. 1 over F equals 1 over DI plus 1 over DO. So next step, we just plug in what we're given. F is 2 meters, so plug that in. DO is 10 meters, plug that in. DI is what we're solving for, so leave that as the variable. So we got fractions here. So there's kind of three different ways to solve it. So I'm going to go over those real quickly. Option one is probably the one that'll make your math teacher the most happy if you find a common denominator with your fractions. So if we got 1/2 and 1/10, the common denominator would be 10. So half of 10 is 5. So 1/2 is equal to 5/10. Okay, so same thing, we just got to solve for DI. So we got to subtract 1/10 from both sides. So 5/10 minus 1/10 is 4/10. So that's not our final answer though, because that's 1 over DI. Okay, so we want to just get DI by itself. We don't want DI in the denominator. We want it in the numerator. So just like subtracting 1/10, we got to do that to both sides. The way we can get DI into the numerator is by flipping it over. So if we do DI over 1, we flip over the right side. Do the same thing on the left side. Instead of 4 over 10, we get 10 over 4. So if we plug in 10 over 4 to our calculator, 10 divided by 4 is 2.5. That's our final answer. That's the DI. So that's your first option. If you're good with fractions, you can do it that way. That's also useful if you have whole number or integer values. But if like your focal length was like 2.7 meters, you couldn't really do a common denominator anyway. So option number 2 is converting all the fractions to decimals. Start the same way. 1/2 equals 1 over DI plus 1/10. So 1/2 is 0.5, 1/10 is 0.1. So you can convert those either in your head or in the calculator. Then you solve it the normal way. Okay, so 0.5, you got to subtract 0.1 to both sides. 0.5 minus 0.1 gives you 0.4. Once again, that's not your final answer. 0.4 equals 1 over DI. So you got to flip over both sides, take the reciprocal. Remember, 0.4, there's assumed in a denominator, 0.4 divided by 1, which is 0.4. So if you flip it over, it would be 1 divided by 0.4 equals DI over 1. So if you do 1 divided by 0.4 in your calculator, you get 2.5 meters. Good sign that it matches your original answer because you should get the same answer regardless of how you do it. Option number 3 is more of like a calculator shortcut. Some people find it easier to put into the calculator this way using the inverse button. If you're using a TI-84, it's on the left side. It's next to the sign button above the x squared button. So it's the x minus 1 button or the inverse button. Okay, so if you're going to put something in a denominator, that's called taking the inverse of it. 1 over a value is the inverse of that value. Okay, so 1/2 is the inverse of 2 and vice versa. So instead of 1/2 equals 1 over DI plus 1/10, we can do 2 inverse equals DI inverse plus 10 inverse. Okay, you don't want to put that into your calculator. Okay, you got to solve for DI still, so you got to move the 10 inverse to the other side, so subtract that over. So 2 inverse minus 10 inverse equals DI inverse. Now to get DI by itself, you got to take the inverse of the inverse. That cancels out. Inverse of an inverse is just nothing, right? So if you turn around and then you turn around again, you're facing forward. So if you turn around twice, you're facing back where you started. Same thing with an inverse. If you take an inverse twice, you're back where you started. So if you inverse both sides, you get parentheses. This is what you want to type in your calculator. 2, then hit the inverse button. Minus 10, hit the inverse button. Close your parentheses, and then hit the inverse again. All in one step, you got it. Put it in your calculator, hit enter, and you get DI equals 2.5. So whichever of those three methods makes the most sense for you, that's the way I would solve it. Personally, I'm going to use option 3 just because it's a little bit quicker in the calculator. But if you need to work it out using option 1 or option 2, that's perfectly acceptable. So key point, since DI is a positive number, that tells us that our image is real. Remember, positive numbers are on the right side of this, the opposite side from our object. So that means the image is on the opposite side of the lens, so it's a real image. So you could shine this image onto a screen and look at the screen to see it. So you're going to look at formation of images in the lab later this week, but here's what the image would look like if you draw in the light rays passing through the lens. Okay, they're going to converge, and you can see on the right side, about 2.5 meters from the lens, is our image of our sunflower. Okay, so notice the focal point is 2 meters, so it's a little bit past that, but not all the way quite to C, which is at 4 meters away. So next thing we need to find is our magnification, big M. So we got our same givens. We add in our 2.5 meters for DI, since we just found that. That's another given. Got to pick the right equation. Remember, there's two magnification equations, high over ho and negative di over do. We don't have high, so we got to use the second one, negative di over do. Okay, note there's a negative sign in the equation there. So if you got a positive number, you're going to make that negative. If you got a negative number, you're going to make that positive. So plug in, M equals negative 2.5 divided by 10. Not really very many ways to solve this. You just got to plug it in your calculator or do the math. So your magnification here is negative 0.25. Okay, a couple things going on here. First thing, our M is negative because our image is inverted. Okay, notice our sunflower on the left has the top pointing up. The image of the sunflower on the right-hand side, the top of the sunflower is pointing down. So our image got flipped over. It's inverted. Second thing to note, M is a decimal here. That means our image is going to be reduced. The image you would see of the sunflower would be smaller than the actual sunflower, and it would be upside down. So just by looking at your magnification number, you can tell whether it's upright or inverted, if it's positive or negative, and if it's reduced or enlarged. Since your magnification is less than 1, that means your image is going to be reduced or smaller than normal. So in this case, the image is 25% of the object's original height, and it's going to appear upside down. All right, on to step 3. Last thing we've got to find is the height of the image. So I added the magnification onto our given section. So M is negative 0.25. So now we're looking for high. So we only got one equation with high in it. M equals high over ho. And notice this one doesn't have a negative sign in there. So you got to keep whatever signs are given there. You're not going to flip any signs. So we just got to plug in, substitute our values. So we get negative 0.25 for M. We're looking for high, and we know the height of the sunflower is 1 meter. So simple math here, 0.25 times 1, and it's negative. The height of our image is negative 0.25 meters. Remember, height has to be in meters, so it's got to match our given height. If our original height was in centimeters, then our final height would also be centimeters. So if we interpret that once again, it's a negative height because our image is inverted, right? If you think about it, you can't have a negative height. You can't be negative 6 feet tall. The negative just means that we're pointing downward. Okay, so the image height is 25 or 0.25 meters, 25 centimeters in the downward direction. So it's an inverted image, and it's 1/4 the size, as we mentioned earlier, 25%. Okay, so now we have solved everything for this problem. We can go ahead and fill in this information into our chart. Okay, so on the top line of the chart, for DO past 2F, which is the example we just did, our DI, our image distance, is between the focal point and the center of curvature. So anytime you're far away, you're past 2F, your image is going to fall in that pocket between F and 2F. Okay, our magnification here is always going to be negative if we're far away. Okay, so it's always going to be inverted. and our magnification will always be less than 1. So we're always going to get a reduced image. So anytime you look at something far away through a convex lens, it's going to look upside down and it's going to look smaller. Okay, so if you look in your notes, you've got 2 more example problems in there for a convex lens. Go ahead and do those on your own. There is a quiz, quote unquote, on eClass where you can check your answers for that. Once you complete this video and the next video, you're going to go on eClass and fill in your answers for those 4 problems. And that's going to count as your daily grade for this unit. Thanks for tuning in. Go ahead and work out those 2 problems and then check out my next video on diverging lenses.